Do you remember when I was talking to you about like the whole metaphor behind logs and indices, and how it's really thinking in terms of time rather than thinking in terms of growth? That's kind of the difference between raising something to a power versus thinking of its equivalent log. Okay. Now, just to add one other sort of grounding underneath this for why logs are so worth it. Like, why take a question which you can do many of these questions purely with indices? Why bother thinking about it in a logarithmic way? And at least one of the answers is because, well, there was a study done, actually several studies done a long time ago, about like children, right? And whether children are born with a sense of number or not, right? Like 1, 2, 3, 4, 5, etc. Is that like a natural inborn thing? Like, is that, all human beings everywhere are going to have numbers? Or is that something which we apply from the outside and it's kind of this foreign idea? Now, I wonder what you think the answer would be.
Isn't this invention discovery?
I wasn't going to say that, but since you mentioned, it actually is exactly that question. Like, is maths invented by humans and therefore it's completely foreign, right? Or is it something which is, common to all of us? It's part of the fabric of who we are. Now, interestingly enough, the answer is, to the question, is number innate in humans or not? The answer is yes. The answer is yes. But not these numbers. We think of these as like, these are numbers, right? When I say to you, okay, think of numbers, this is what jumps to your mind. This is invented, okay? The technical term for this, which you've probably just thinking of, is numbers. This is arithmetic, okay? This is numbers going +1, +1, +1, etc., right? Another way of thinking about it is it's a linear way of looking at numbers because numbers grow at a steady rate. Really interesting experiment was done. They went into jungles, places where people don't have formal education and like, oh yeah, I did Year 11 maths, that kind of thing. Places where that doesn't exist, okay? And they said, okay, what's halfway between 1 and 10? 1 and 10. Now, just not worrying about like precise averages and all that kind of thing. Most Western people would say 5 is halfway. Don't 5.5 me, don't worry. You get the point, right? That 5 arithmetically is ish halfway between 1 and 10. But in these villages, right, places where they understood numbers and all that kind of thing, they just didn't have a formal system. When asked what was halfway between 1 and 10, they didn't say 5. Universally, they said 3. What? Now, why would it be 3? Okay, and it doesn't take that much effort to think about it. Like if you see a group of people, okay, so you see a group of people, there's like 100 people in the crowd, okay, and you like add one more person. That group looks pretty much the same. Okay, it looks pretty much the same. 100 people, 101 people. So there's like intuitively, to like say a little child, right? The difference to say that the difference between 1 and 2 is the same as the difference between 100 and 101, that doesn't make sense because 2 is twice the size of 1. You've doubled the group, whereas you've hardly made a change. You wouldn't even notice. If you looked away and then turned back and there's one more person there, you'd say it's the same size, right? So the reason why 3 is halfway between 1 and 10 is because, well, 3 is 3 times bigger than if there were one thing there, right? And if you wanted to get to 10, well, that's roughly another 3 times bigger, okay? So this is a logarithmic scale. Right? In the same way, like all of our senses work in exactly the same way, right? If you put your hand in like room temperature water, okay, room temperature, so it's like 25 degrees, okay? And you increase the temperature to like, 26 degrees, you would feel no change, right? But in order for you to feel like, oh, this is, if I boosted this up to like 50 degrees, it's quite hot, right? Now that difference you can feel because it's double. Right? It's the distances between things, right? As the difference between 25 to 26, right? Versus like 50 to 51, right? These kind of differences here of thinking, oh yes, that's the same difference. It's not the same difference, right? So logs are actually your inbuilt number system, right? And we beat it out of you thoroughly because as soon as you can, like even before you can talk, as soon as you can make sounds, we say 1, 2, 3. And Sesame Street gets in on there and teach you songs for like 1, 2, 3, 4, 5. I still have it in my head, right? The song for 1 to 12, back from when I was, 3 or 4 years old. So all of that to say, logs actually, there's a real argument to say logs are the real numbers, right? They're the actual numbers that we all think in terms of. And this is a construct on the outside. No wonder so many people have trouble with it. So we're putting all these levels of abstraction on. How do you even start to work with this thing? You have a lot of laws at your disposal that you can use to manipulate it in terms of these pieces, right? Okay, so there's an easy one that jumps out at you. What's the first most immediate thing you can see?
25 times 3.
Okay, good. 75 is a multiple of 3. It's not even, which in a second will cause us some problems, but that's okay. We'll rewrite this as log base 10 of 3 by 25. Okay, so far so good. Now with your log laws, because this is a product here, what does this really mean about the log?
Log base 10 3 plus log base.
Yeah, good. This is actually 2 different logs that have been added together. That's what produces the product. So I've got log base 10 of 3 plus this. Okay, so immediately I've gotten rid of this. That's good. I've made the problem simpler. Okay. This guy over here though, looks a bit awkward. Not impossible to work with. Someone give me a suggestion. What can we do with this thing? Yeah, right. Okay, let's go a step back before that, right? This thing here, 25, is 5 squared, right? So it's really important because it's all about showing you logic, right? From here, I can use my power law. I can bring that out the front. Okay, so that's going to be y plus 2 log 10, 5. And at this point, some of you hit a brick wall because you're like, what do I do here? This is not a product of anything useful. 1 and 5, right? It's prime, right? So I can't do this decomposition trick. What can I really do with this thing? Now you still need to keep thinking in terms of products and division. Yeah, Eddie.
5 is 10 divided by 3.
Very good. So this step is really hard to see because do you remember when we were talking about trig functions, trig identities, and sometimes you have to make things harder before they become easier, right? So you have to turn 5, which is simplified, into something more complicated, which ironically you can then work with, right? So the key is to say, well, I have to work in tens. There's no other direction I can go in. It's like if you went down to the bottom, you got sines and cosines, and you're like, I'm done. I can't do any more identities to make it simpler. I have to climb back up to try and get somewhere. This thing, I can apply the same trick but in reverse. You can probably see the pieces now. This over here, which is log 10 minus log base 10 of 2, which is one of the pieces I have. Okay, so how long does it take 10 to grow into 10? Answer, 1 time period. And this I already have defined as x. So I'm pretty much done, right? I suppose you could expand. Plus 2 minus 2x. And that's all you need to do. Okay, so you can see, just like I did, right, that here is the critical step. Here's the hard part. The rest kind of goes on autopilot, right? But that's when you need to train yourself to think, what else can I use here? And the answer is you can use this. It's just not immediately obvious.
You know what I did? I did 27 minus 2, and I was trying to re-express.
You're like, 27! 20, I'm going to make it in 3s, right? You'll know, right? So because in exactly the same way that with indices, when you multiply them, it becomes addition, right? You must work in terms of products and factors. It's the only way you can work with logs in order to then break it apart into different pieces. So that's why, making that 6 minus 1 or 27 minus whatever is never going to get you very far.
Yeah.
Okay.
So why don't you use like 300 over 4 at the beginning?
Oh yeah, sure. Like if you look at that and you're like, haha, 304, that's what I think of first, then be my guests. No, so seriously, if you do see it, and like after, now that you know this trick of, doing this, maybe it will come quicker to you next time, but it sure isn't like, I'm not that kind of student, so they don't come as obviously to me, but go for it. You have my full permission.